This is an optional video. The purpose is to illustrate the details of how this expected value of lifetime value works. Now, any student who really has a good grasp of probability theory doesn't need to watch this video. But for those who may be a little bit shaky on it, what I found is that demonstrating the details of the terms in this formula in Excel is a good way to really understand it. I'll just remind you, I already proved it for you with the math here, but let's go do it in Excel. I've set it up where, let's say we have a 90% retention rate, meaning I keep 90% of my customers every month, or you can think about the customer flips a coin. There's a 90% chance of a heads, 10% chance of a tails. Let's just use a period discount rate of 1%, and suppose that the monthly cash flows are $10. What I've done down here is to write out all possible values of t. Now, I exaggerate slightly. Ideally, I could take this out to infinity. I can't really do that because Excel doesn't have that many rows. 514 is close enough to infinity for our purposes. Let's start with the PMF. So what is the probability that I lose a customer in period 1? Well, the answer is simply 1 minus the retention rate. What's the probability that I lose a customer in period 2? Well, I've got to retain the customer once, so that's $1, times losing the customer, which is what I had before. Now, if you think about it, I'm set up to just copy this down. So if I wanted to keep a customer one more period, I would multiply whatever I have now by the retention rate. I've also written the sum up here. And so if I've done this correctly, since this is a probability mass function, it had ought to sum to 1. So let's just go check that and make sure that it works out. So if we take B7 through B1000 is close enough to infinity for our purposes, you're going to see that it equals 1. What is the expected value of t? If you think about this, if we go back to my document camera, that's this formula right here. We're going to take the value of t times the probability, and that had better equal 1 over 1 minus r. Well, let's just go see if it works out that way. So I'm going to take the value of t times the probability and copy it down. Now, if I've done this correctly, it should equal 1 over 1 minus the retention rate. And so what I just did was to work out this formula. Let's go compute the sum now. So the sum, I can just copy the sum over, should equal 10 if I did it correctly. And it looks like I did do it correctly. Cool. Well, let's now get to lifetime value. So what is lifetime value? Well, we're going to take the present value times the probability. So let's go work that out. I'm going to add a column, which is, I'm going to label CLV given t. Suppose I know the period in which a customer cancels. This would be the value of that customer. So if a customer goes away in period 1, what's that customer worth? Well, clearly it's $10. But let's go use the present value formula in Excel to compute this. Now, I could use the closed form expression that I derived 2 videos ago, but Excel already knows about that, and so let's just go fill it in. So the rate is going to be $2, the number of periods is A7, the payment amount is $3. Now, let's do immediate annuities. So if I say comma, so skip the future value thing, the type takes the value 1 to indicate an immediate annuity. So if I did this right, this should be $10. Now we're actually going to have a small problem because it makes it a negative. So let's just go stick a negative sign in front of this, and we get $10. We are ready to copy this down, so let's go do that. And let's just interpret some of these numbers. So what this is saying is if I had some additional information that the customer goes away in period 2, What that would be worth to me today is $10 that I get today, plus the promise of $10 that I'll get in 1 month, but that's not quite worth $10 to me. It's only worth $9.90, bringing me to $19.90. Now, what you'll see is that the further out we go, the value of an additional payment decreases. And so this value the value of CLV, given that I know when you cancel, is going to start approaching an upper bound. And so we're getting fairly close to that upper bound, I guess. Well, let's go find the mean of CLV now. So what is the mean of CLV? Well, that's just this formula. We're going to take whatever the lifetime value is, so the present value, if I know t, and weight that by the probability of that occurring. So let's go work that out. We're going to take the probability of that occurring times the present value, and we'll copy this down. And if I add these up, I'll get the expected value of CLV. We'll just make that a dollar amount. Now, if I did this right, I should get this formula. So remember, I'm using immediate annuities right now, so it should be m times 1 plus d over 1 plus d minus r. So let's just go type this in. M is B3 times 1 plus the discount rate, so that's B2, all over 1 plus B2 minus the retention rate, which is B1, and what we get is exactly what we got the hard way. Now, another reason for doing the spreadsheet approach is we're going to have to do something similar to this once we get to the general retention model, because we're not going to have this nice closed form expression for it. So I think there's some value to knowing the spreadsheet approach, even if you understand all the algebra.